Okay, so given that the following are three consecutive terms of a geometric sequence, find k. So we've got k minus 4 is one of the terms. The next term in the sequence is 2k minus 2. And the following term in the sequence is k squared plus 14. God, first guess. Okay, so looking at this sequence, what do I know about it? What do I know about geometric sequences? Yeah, there has to be a common ratio. I don't know what it is, but if I multiply this by the common ratio, I get this. If I multiply this by the common ratio, I get this third term. Correct? So who can tell me what r, can somebody tell me what r is equal to in terms of k? No, you don't just, no, you don't need to work anything out. You should just be able to tell me what is r equal to in terms of k. There's two answers you can give me. Here's another question for you. What is r in this example? 2. How did you get that? What? Yeah, you did 8 divided by 4. What else could you have done? No. You could have done 16 divided by 8. You could do 32 divided by 16. Correct? So what is the formula for r in terms of k? It's that divided by that. That makes sense. Or it's also equal to
2k minus 2 over k minus 4.
2k minus 2 over k minus 4. Now, here I've got an equation involving k's. I've got another equation involving k's. I know they're both equal to each other. And what am I trying to find again? No. Like, what is the question saying? I'm trying to find out k. So what do I need to do here with these equations? I need to solve it for k, yeah? I need to solve this horrible looking equation for k. Any thoughts on what I could do? How could I get rid of the fractions first off? Multiply, okay. So, have you done cross multiplication? That easy.
Yes.
Yep, so we're going to cross multiply. So I'm going to have k squared plus 14. And I'm going to multiply that by k minus 4. And that's equal to 2k minus 2 multiplied by 2k minus 2. So I've just cross multiplied. Is that okay? Have you seen that before? You promise? Okay. What do you think your next step is? Expand, right. Do that for me. Okay, so we've expanded our brackets. We have this on the left-hand side, this on the right-hand side, and then we're going to make it equal 0. So just by taking all of this to the other side, and I am left with this equation, which we have to solve for k. Now this is where your calculator is really, really important. Now you can do this without a calculator. We just haven't covered it yet, but we will do at some point. It is actually only HL. Need to know how to solve this by hand. Okay, so Nick, you've got a get out of jail free card, but you can solve this really easily on the calculator, and this is comes up on the calculator paper all the time. Okay, so we're going to do it on the TI Inspire. You can do it on the TI 84, but it is easier just to do it on this. And how we're going to do it is by going to menu, and we're going to add graphs. Okay, so Nick and Zoe, if you just watch for the minute, because you're both got Inspires, and this is how you'll do it. Sorry?
This is the Inspire, right?
Yep. So we're going to put it in as a graph. Are you okay you at this point?
You said menu and then...
Menu, and then I need to go back. I can't, so what can you see at the minute?
I see, how do I get that back there? Yeah. Up there, yeah.
Yep, so you want to add graphs. Okay, and then we're going to put our graph in. So I've got x cubed. So x to the power of 3. And then I've got minus 8x squared minus 8x squared. And then plus 22. No, I'm using x's here. The question is involved in k, but it doesn't matter, yeah? Minus 60. Are you okay with that? Ashlyn, have you got that on yours, yeah? And Greg?
I somehow went to F99, so it just went there instantly. I can't go back, so I'm just going all the way now.
Okay, so I've got my graph, and I want this graph whereabouts? At 0, right. And where does it equal 0? Right there, okay. And I can find out that point by just going to menu. I want to analyze graph. And I want none of those things. I want to go to trace, sorry, my bad, trace. And I'm going to graph trace. And you can just move your cursor on your graph. Sorry, I'm up the wrong bit. Okay, so it gives us a 0, and that gives us the point where it crosses. So that tells me that x is equal to 6, and when x is equal to 6, it gives me a value of 0 out. Okay?
I'm sorry, how did you zoom in?
So you just go to menu, you go to trace, and then you go to graph trace, and then you should be able to move your cursor left and right, and it will move the point.
Thank you very much.
Yep. Ashlyn, yeah, does it work on yours? Good. So that when k is equal to 6, this whole thing is equal to 0. Yep. So that is our answer. So your calculator is so important. It will do all of this for you. And you'd be surprised that students, even students in deep, that when they get an equation like this, they'll either try and do it by hand in a calculator paper, or they will have no idea how to solve it, when really it is a case of just putting it into your calculator, looking at the graph, and seeing where does it equal 0. Okay? So another way you can do it is by going just into your general page on your calculator, hit menu, algebra, polynomial tools. You want to find roots of a polynomial, and we have a degree, how many? What's the degree of this equation? 3, because it's to the power of 3. And then we put in our values, so this is equal to 3 is equal to 1, yep. 2 is equal to -8. Stop packing up and watch, please. 1 is equal to 22. And our constant is -60. And when I hit 0 equals, hit enter, it gives me the value of 6 out. Alright, so the calculator will do it. This is probably a nice way. I would do it like that, actually, rather than graph it.
I don't know. I'll try it again.
Okay. Now, please, the calculator is your friend in this. If you do not know how to use your calculator, you are not going to do very well in this exam. This is so important. And